In this video, we're going to take a look at what it means to have a system of linear equations and how we can find the solution to that system. So first, let's take a look at a system. So a system is just a set of two or more equations. In this one, we're going to be talking specifically about a linear system. So let's type up a couple of linear functions. So 3x minus y equals 2. That'll be our first line. Graphed in standard form, and then we have y equals 1/2 x plus 3. So we have two lines here, a line in standard form and a line in slope-intercept form. And we can see that these two lines have a couple key features, right? We have x and y intercepts. The slope here is 1/2. But we also have this interesting point here where our two lines intersect, 2, 4. And you can see that Desmos automatically highlights that point. Now, why is Desmos highlighting this point? Well, the reason they highlight this point is because this point represents the solution to this system of equations. A solution to a system is just a point of intersection or a point that lies on all of our lines in our system of equations. So because this point lies on both of our lines, we say that it is the solution to this system of equations. Now, to find a solution to a system, we have three different ways that we can do that. Just like we did here, we can graph, or we can use a method called substitution and a method called elimination. The last two methods we will talk about in a future video. For this one, we looked at how to find this solution by graphing. So this is one possibility when you are graphing a system. You can end up with one solution. Let's take a look at another possibility, what happens when we are looking at systems of equations. So if I take my red line and transform it a little bit, changing its equation to be x minus 2y equals 2, I get this here. So now this line has a slope of 1/2, right? Up 1, right 2. This line has a slope of 1/2, up 3, right 6, reduces to be 1/2. So because these have the same slope, we know that they are parallel. And one feature that we know about parallel lines is that they never intersect. So if a solution is a point of intersection, what would be our solution in this case? Well, we have none. There is no solution. So parallel lines have no solution, and sometimes they are said to be inconsistent. That terminology comes up frequently when you're looking at systems involved in matrices, and so they would say that it is an inconsistent system. It basically just means that your two lines have no solution or that they are parallel. So let's take a look at the last scenario that can happen when we're looking at a system of two equations. So if I change this red line again to be x minus 2y equals -6, we can see that now my red line is just graphed exactly on top of my blue line. So if I were to get rid of my red line, we can see that it's just exactly the same as the blue line. So what does this mean? Well, technically, our red line intersects our blue line at every single point that it's defined for, which means that our solution would be every single point on this line. And the way that we say that is we say that it has infinitely many solutions. Again, in talking about matrices, when you have something that has infinitely many solutions, they will sometimes call it a dependent system. So if it has infinitely many solutions, basically it's just the same line in a different form. We say that this system is dependent. So there are three different possibilities. We saw if they just intersect at one point, it just has one solution. If they were parallel and never intersect, it has no solution, and we can say that the system is inconsistent. And if they are the same line, right, they intersect at every single point, it has infinitely many solutions, and we say that the system is a dependent system.